Okay, this is 12.7 Exponential Growth and Decay, and we're not going to really get serious about this today. We're going to just basically make tables for graphing. We're not going to graph. We're not going to look at a lot of word problems for this today, maybe one or two. Basically, we were sticking with making tables for graphing, which you will do next year. I just want to expose you to this type of function so that when you see it next year, it's not something you just totally blindsided by. It's not hard, but sometimes people can get confused for this very reason. In an exponential function, the variable x is in the exponent part of the problem. So an exponential function in two variables can be written in this form: y equals ab to the x. Now b is the only thing here raised to the x power. A is not. A is multiplied to this. Okay, b is the base, x is the exponent. A would be the coefficient of this in a way. A is not 0, B's got to be greater than 0, and B cannot be equal to 1. Now it's got to meet all these to be an exponential function. Okay, a quantity that increases from left to right shows exponential growth, while a quantity that decreases shows exponential decay. Okay, we see exponential growth in something like a virus, where somebody may get a virus and then infect quite a few other people, and before you know it, a lot of people have the virus. Whereas exponential decay, where something that decreases quickly and then tends to level off over time, like a computer. You may buy it for $1,000, and a year later it may not be worth 500. 2 years later it may not be worth 100. But then after a while the price decreases at a slower rate. That would be exponential decay. Something like a car. Once you drive a car off the lot, it's $2,000 less in value. So that's exponential decay. Okay, so we're just going to make a table for these. We got just a few examples to do. So let's look at this one, and with all these tables, we're going to choose the same numbers: -2, -1, 0, 1, and 2. Okay, so you'll kind of make it like this. I don't like drawing horizontal lines with this tablet, but it worked out okay. Okay, here's our table. Now we're just going to plug, these are x values, these are y values, okay? We're going to plug these in for the x and then get the y. So if we plug 0 in for x, 3 to the 0 power, well, anything to the 0 power is 1. Okay, we learned that in chapter 4. We should have learned that in chapter 4. 3 to the first power is just 3. Then 3 to the second power is 3 squared, which is 9. Now going back, when I have 3 to the -1, which I do if I plug -1 in for x, that just flips this. Remember, the negative changes positions causes the 3 to change positions. That equals to 1/3. Now when I put in -2, the negative will change positions with it, but the 2 squares it. So that becomes 1/3 squared, which is equal to 1/9. So this is just 1/9. And that's it. We made our first table. All of these are basically the same. Once you get a few of these down, you're going to learn that they're pretty much all the same. I'm backing up here so we can do the next one. Okay, 5 to the x, let's start with 0. 5 to the 0 power is 1. 5 to the first is 5. 5 to the second is 5 squared, which is 25. Going back, 5 to the -1 causes us to flip it, so it becomes 1/5. It changes positions with the 5. The 5 to the -2 causes the 5 to change positions. The negative does, but then the 2 squares it. So instead of 25 for 5 squared, 5 to the -2 is 1/25. Okay, and that one's done. Let's look at this next one. Okay, this one has actually a coefficient here. So we have to evaluate the exponent and then multiply by the coefficient. So 4 to the 0 power is 4, but 4 times 3 is 12. Okay, again, I don't raise the whole thing to the 0 power. I just raise the 4 to the 0 power. Okay, 1, if I put a 1 in for here, in for x, I've got 4 to the first, which is 4. 4 times 3 is, I'm sorry, that totally messed up. Let me back up just a little bit. If I put 0 in, 4 times to the 0 power is 1. 1 times 3 is 3. That's better. That confused you. 4 to the first is 4. 4 times 3 is 12. 4 squared is 16. Okay, 16 times 3 is 48. 4 to the -1, remember, if I've got this and I put in -1, 4 to the -1 just flips the 4, basically. That gives me 3 times 1 over 4. Well, 3 times 1 over 4, if you remember how to multiply whole numbers and fractions, is just 3 over 4. Okay, same way with 3 times 4 to the negative 2. Okay, 4 to the negative 2 is 1 over 4 squared, which is 1 over 16. Well, 3 times 1 over 16 is equal to 3 over 16. And that one's done. Let's back out of this and look at our next one. This is 2 times 3 to the x power. Well, 3 to the 0 power is 1. 1 times 2 is 2. 3 to the first power is 3. 3 times 2 is 6. 3 to the second power is 9. 9 times 2 is 18. Okay, 3 to the negative 1 is 1 over 3. Multiply that by 2, you get 2 over 3. 3 to the negative 2 is 1 over 9. Remember, the negative changes positions, the 2 squares it. 1 over 9. 2 times 1 over 9 is 2 ninths. That's it. Let's look at the next one. Okay, I did not erase this for some reason last time. Let's look at this. Okay, these are, we're dealing with fractions here, and they're not hard at all. Once you've done one or two, they're all the same, as is all of these. That's a bad 0. Let's try our little table. Horizontal line's a little better there. Okay, so here I've got 1/4 raised to the 0 power. Well, anything raised to the 0 power is 1. That's easy. 1/4 to the first is just itself. Anything to the first power is itself. 1/4 squared. Well, remember, 1/4 squared is 1 squared over 4 squared, and that's just 1 over 16. Okay? Let's look at negative 1. Well, if I put a negative 1 here, that flips this. It changes positions with both, so that becomes 4. Not 1 over 4, it becomes 4 over 1, which is just 4. If I put a negative 2 here, it flips, the negative flips it, but the 2 squares it. So instead of 4, we get 16. Notice here, this is decreasing as we go from left to right. This is an example of exponential decay. Okay, decreasing as we go from left to right. Okay, let's back out of this and let's do the next one. Okay, 1/6 to the 0 power is 1. 1 times 2 is 2. 1/6 to the first power is 1/6. 1/6 times 2, well, this is what that looks like. Okay, remember that's one, we're going to cross reduce here. That gives me 1/3. 1/6 to the second power is 1 over 36, because I squared both the top and the bottom. Well, that gives me, when I multiply that by 1 over 36, that's 2 over 36, reduces to 1 over 18. Go to the negative 1. Negative 1 flips this over, so it's 6. 6 times 2 is 12. Negative 2 flips this over and squares it. That's 36 times 2, which is 72. And notice this is decreasing rapidly as we go from left to right. Okay? Let's look at the next example. And get out of that. There we go. 1/2 to the first 0 power is 1. 1 times 3 is 3. 1/2 to the first is 1/2. 1/2 times 3 is 3/2. 1/2 squared is 1/4. 1/4 times 3 is 3/4. Okay, 1/2 to the negative 1 is 2. 2 times 3 is 6. 1/2 to the negative 2, you flip it over and square it. That's 4. 4 times 3 is 12. There you go, decreasing from left to right. Okay, the value of a car decreases over time, which I've already mentioned. Suppose your parents buy a car for $10,000. The car's value T years after purchase can be approximated by the function V equals 10,000 times 0.9 raised to the T power. After how many years will the value of the car be less than $7,000? Well, you want to do a table like this. We're going to have 0 years, 1 year, 2 year, 3, 4, 5, 6, and 7. And I suspect here I've got my numbers a little close together because we're going to have prices. But we're going to figure this out for each year and see when we dip below 7,000. Okay, so at 0 years, 0.9 to the 0 power is just 1. 1 times 10,000 is 10,000. How did I get a black pen here? We'll use it anyway. Now at 1 year, raise 0.9 to the first power, that's just 0.9. Okay, 0.9 times 10,000 equals 9,000. Okay, Okay, now we're going to raise 0.9 to the second power. That's 0.9 squared times 10,000. That's going to equal to 8,100. Okay, now I don't know how that happened. We are really, let me get this, see if I can get this pen working correctly. Maybe not, we'll see. Let's raise 0.9 to the third power. 0.9, let's see. That's going to 0.729. That's going to be 7290. Okay, so this is ugly, I know. I don't know what happened in the middle of this, but somehow I've lost my pen. I'm just going to pointer here. So it's 10,000, 9,000, 8,100, 7,290. Now for the fourth year, we're going to raise 0.9 to the fourth power. Okay, then we're going to multiply that by 10,000. That's going to give us 6561. Okay, so as we see, first year 9,000, we lose 1,000. Second year we lose a little less. Third year less, and in the fourth year we actually dip below the $7,000 mark. So after how many years would the value of the car be less than 7,000? It would be here, 4 years. Okay, and so we did that by just using this function and plugging t for time. That's what we did for years here. We plugged that in, raised this to that power, and then multiplied it by 10,000. You got to raise this to the power first, and then multiply it by 10,000 last. Okay, and we found out after 4 years it would be 6,561. And that concludes today's lesson.